This is lesson 9-3, surface area of rectangular, no, non-rectangular prisms, triangular prisms, I think. Sorry, I was distracted because when I clicked the button, it did something weird. So anyway, yeah, we are doing surface area of triangular prisms. This is not what I want. See, it glitched out. All right, this is what I want. Make a net to represent a triangular prism. So this is page 505. A triangular prism is a prism that has triangular bases. The net of a right triangular prism is composed of two congruent triangles, called the bases, and three rectangles, which are the faces or the sides. So because triangles have three sides, the triangular prism also is going to have those three sides and then two triangles as the base. So unlike the rectangular prism, we're actually only dealing with 5 different surfaces here to find our surface area. And 3 of them are rectangles and 2 of them are triangles. Okay, I just did that. Click. Oh my god, it's glitching out. Hopefully we make it through the video here without this thing completely crashing. All right, so example 1, make a net to represent a triangular prism. So this works very similarly to the rectangular prism situation. You can unfold the triangular prism out into a net to represent the different sides so you can see what the layout looks like. So here's a triangular prism. Notice that these triangles are right triangles, these two bases here, and then you can kind of tell from just the image that 2 of the sides are going to be congruent, but this one is maybe not so much going to be. It just really depends on the triangles. Let's see what it looks like 3 years from now. Okay, so we can build the net. So we're going to start off with the base, which is this triangle right here. And so if we have this base, we are taking it straight from this. Our bottom of the triangle, the base of the triangle is 12 feet. The height here is 5 feet. And then we've got a third side, and that's going to be 13. You can tell from the prism. Okay. All right. Then we can fold this out and have it include the bottom of our prism and then our other base, which is our other triangle. The triangles are congruent. We've got 2 5s, 2 13s, and 2 12s here. And then we've got this bottom, and that is going to be 12 by 15. They're not labeling the 15 on this side, but this is also 15 as well. So let's put that. Okay. Then we've got these 2 sides to deal with. So let's just put this one here. This is a rectangular face. We can get our dimensions again straight from the prism itself. If the length is 15, then our width is going to be 5. And then finally, we've got another situation. So I said earlier that it might be congruent. It turns out it's not because there's a slight difference in the sides of the triangle here. So this top part of our prism, we've got 15s and we've got 13s. So it's not quite the same. It's a little bit bigger than this bottom piece, which is 15 by 12. This one's 15 by 13. So make sure you pay attention to the dimensions. All right, is there one more thing? Oh, it just labels it. Wow, amazing. Cool. So then, once you have your net, as we did before, you can use that net to calculate the area. So this check is drawing out the net. Many of us will get to a point where we skip the net piece and you can just go straight into the surface area. But I do want you to practice drawing the net just for familiarity purposes. So do the check on page 507, and then we will move on to surface area, which you will find is quite similar to rectangular prisms. Difference being we've got a triangle in the mix. All right, so let's go ahead and watch this.
The surface area of a three-dimensional figure is the sum of the areas of the faces. To find the surface area of this triangular prism, find the sum of the areas of the two triangular bases and the areas of the three rectangular faces. You can use a net to find the surface area of the triangular prism. A net is a two-dimensional representation of a three-dimensional figure. The shapes in the net of this triangular prism are two triangular bases and three rectangular faces. First, find the area of the triangular bases. Since each base is a triangle, find 1/2 of the length of the base times the height. The triangles are congruent, so the area of each triangular base is the same. Next, find the area of the rectangular faces. Because the bases of the prism are isosceles triangles, two of the rectangular faces are congruent. Find the area of one of the congruent rectangles by multiplying length times width. Then, find the area of the third rectangular face. Multiply length 9 inches times width 6 inches.
All right, so different
Finally,
from
find the sum of the areas of all the faces. Add the areas of the two triangular bases. The two congruent rectangular faces, and the third rectangular face. The sum of the areas of all the faces is 168 square inches. So, the surface area of the triangular prism is 168 square inches.
Hey, dang, bro talks so slow. I thought he was done. Okay, I was gonna say the difference between this one and the one we just did in the last example is this is an isosceles triangle, which means two of the sides are the same, which means two of the rectangular sides or faces are actually congruent as well. So the short way of saying this is you find the area of all of the faces. The triangles are congruent, so you can do that just once and multiply by 2 or add them twice. Then find the rectangles and then you add them all up. It's exactly the same process. The only difference here is that you have a triangle, so you need to remember the area formula for triangle, which is half times base times height. Okay. Example 2, they're going to give us another triangular prism here. All right, so we actually just worked with this. This is the same net that we just did in the last example, not the one in the video, but the one prior to that. You might look familiar. And so we're just going to use this net now to find the surface area. So in order to do that, we are going to find some areas and add them together. So we've got the bases, which are our triangles. To find the area of the base of the triangle, we have half times base times height. So that is half times 12 times 5. Remember that you can tell which one is the base and which one is the height in a right triangle because they make a perpendicular. And if they don't do that, then they give you that little dash line, which would be perpendicular. So we have 12 times 5 times half, or divided by 2. So 12 times 5 is 60, times half is 30. So we have two of those triangles, which means that we are dealing with a total of 60 square feet for both triangles. The bottom is just a rectangle, so we just take our length times our width, so 12 times 15, which comes out to be 180. So there's only one of those, so we have 180 there. Our top is 13 times 15, and that gives us 195. And then finally, 5 times 15 for this side, which is 75. And then what we would do is add them all together. So 60 is the two triangles combined, and then 195 plus 180 plus 75 equals 510. So we've got that as our final answer here. Yay! Okay, there's another check for you to do, and then there is one last example that we will do that kind of says the same thing. Well, we're going to do it anyway. So example 3 on page 511. is another. Use the net to find the surface area of the triangular prism. Now, again, oh my gosh, someone in PE is screaming like a psycho. If you don't like this net thing, if you're ready to move past the net, you can just figure out the areas of the faces. You just need to be careful. It's a little harder to see sometimes with these triangular ones. Just make sure you know how many faces there are so that you know how many times to do the area so that you can add them together. So in this case with triangles, we've got two triangles plus three sides, so there's five surfaces to make sure we have the area of to add them together. But you can just be like, well, here's our triangle, so we can go half times base times height, multiply that by 2, put that off to the side. Then we could go 2 times 1, and then we could go 2, let's see, 1 times 2 again. Like it's a little harder to see this way, as you can see, but in this particular case, these are actually all ones, so it makes it a little bit easier. But anyway, if that doesn't work for you, you of course can resort back to using the net. That is not a problem. You just need to fold it out. They're nice in this case, and they give it to you. So we can see that the triangles are half times base times height. In other words, half times 1 times 0.9, or half of 0.9, which is 0.45. And then we have two of those, which means we're back to 0.9. So that's our two triangles together combined. And then these triangles are equilateral, so all of the faces are the same, which means we can just do one time and then multiply that by 3 because there are 3 of them. So we've got 2 times 1, which is 2, and then 3 of those makes it 6 total. And then we can add those up to get our total surface area, which would be our two triangles are 0.9 in total, and our 3 faces are 6 in total, so we have 6.9 as our total surface area. Okay, and then this is your final check here, and that's the end of that. Ta-da!